Hello everyone. Welcome to this recorded session of Surveyaan GeoWorkspace. In this particular session, I would be going through what all features the Surveyaan GeoWorkspace have currently and how to use them. That would include uh, how we process the data, then how we see the processed data, how we measure few of the things like area measurement, volume measurement, the point measurements, and different kind of measurements which are available in the Surveyaan GeoWorkspace, as well as we would look into what all data we would be able to export from the Surveyaan GeoWorkspace. So we'll start with first with how to create a project in the Surveyaan GeoWorkspace and how to start it processing. So the screen which you are seeing right now is a dashboard screen of Surveyaan GeoWorkspace, in which there are consolidated view of your entire account, like how you are operating the account. So here you get how many projects you have done, what all areas you have processed. Here you are getting a chart day by day, basically based upon how much area you are processing day by day. And then you have here the recent projects, then you have recent outputs here, and the projects, if any is in processing, that would be shown here, and if there is any pending project which has been created but has not processed yet, would be shown here. So this is just a dashboard. If you wanted to go into the detailed projects, you can go from here and you can search your projects also if you want from here. Also there are a few filters here, like you can see how many projects has been completed, you can see how many projects are in processing right now, and you can also see how many projects are in start processing, like projects have been created but have not been started processing yet. So all of these things you can see here. So there is a plus button in the top side of the screen. When you click on this plus button, you would be guided to create a project. So you can write any name. I would write demo webinar here, and then I would give what would be the date of the demo. So today it is 29th July 2021, on which I'm recording this particular webinar. And then the guy who have done the survey, he can give his phone number. So if in any case, if we want to communicate with the person, we could communicate with him. And then there are two categories of the surveying. One is general land survey and other is rooftop scan. So general land survey should be selected when the land is, or the terrain is the major concern of the survey, whereas rooftop scan should be selected when buildings are the major concern of the survey. So so you may have the doubt, like what would be done if it is building as well as the land. So if in the building, as if there is a data in which there are buildings and there are land, so and both are concerned, then also you need to start processing in the rooftop scan. Okay, so we would select the general land survey for now, and then there are two options of the surveying: GCP methods or without GCP methods. So GCPs are ground truth points, which usually in the drone survey, surveyors place on the ground and then take its point using DGPS, whereas in without GCP way, the surveyors rely basically on the GPS data for the processing, or the GPS data for the surveying. The GPS data may be error prone if you only use the GPS in the case of larger area, whereas the GCP method would be accurate as the DGPS is. So for this session, I would go for the GCP without GCP data, because I would not have the GCP data with me right now. So I would select without GCP here, and then there are two options here, so cropped or uncropped. So in the cropped session, the entire map would be cropped at the extreme boundaries of the photos taken. So there, if there are around 200-300 photos have been taken, so their coordinate extreme polygon of the entire points would be created, and the entire map would be cropped at that point, whereas in uncropped we would not crop anything, and the raw, however the map would be generated, would be given to those who are processing the data. So I would select uncropped for now, and then we'll go to next point. Here the software would ask for uploading the photo data, so I would upload only 10 data for now, and then I would start the processing. So, this is just to show how you can process the data. So that's what I'm doing. So if I'll go here and go to the photos, I would select 10 photos here, and then I would do start upload. The photos would start upload, and once it would be uploaded, a project would be created, the screen would be refreshed, and you would go into the project explorer. So we would wait for data to upload, and then we'll move to the next session, like how we can start the processing, and what would happen if we start the processing, like what all changes would be reflected in the entire project when we start the processing. So let's wait for a few minutes. So the project, these photos have been uploaded and the project have been created. So in the project explorer, there are three views in the way you can view the photo data. One is this map view. On the map view, you can see there are multiple photographs on the map. So for the user's convenience, it is important to filter out some of the photos if he or she don't want to process it. So this particular view is very helpful in that. Suppose if you want to delete some of the photographs, you can select the photographs from here and you can delete from here itself. Otherwise there are two more view. One is list view. So from the list view also you can select everything and you can delete, or you can select whatever your choices are. So you can select multiple photographs and you can delete if you want. Otherwise, you can also view the photographs by clicking on the photographs, and an entire photograph would be opened, and you can inspect the photographs from the GeoWorkspace only. Otherwise, there is one more view that is called grid view. In the grid view, your photo would be shown in the project explorer itself. Suppose if you want to upload more photographs, you can click on this plus button and you can upload the more photographs from here. Okay, so I would select one photograph for now, and I'll show you how to upload it. So once the one photograph has been uploaded, the uploading would start, and once the uploading would be done, the photograph would be reflected here in the project explorer itself. So now the photograph have been uploaded, but wait till here upload complete comes. So once it has come, you can see there is one more photograph added into the project. Okay, so this in that way you can upload multiple photographs. Now I'll show a few of the things. So this GCP is for GCP processing. Right now we have not selected any GCP data, so it is not showing the GCPs like GCP 1, 2, 3, 4. If we would have selected the GCP and we would have entered the GCP details at project creation itself, that these GCP would be reflected here, and users need to select the GCP photos corresponding to that particular GCP. So we would rather do this particular exercise in the next webinar. So then we have a project output button here. You would see that there is no project output yet because the project output have not been generated yet. We need to start processing for generating the project outputs. Then in the invoice section, you don't have the invoice yet because the processing has not been done. And in the project settings, you have the same settings which you have entered while creating the project. So you can change some of the settings except the project name. You can change all the settings and you can update settings accordingly, and you can use this button to update the settings. And there is one more option here to delete the project. So once the project, if the project has not been processed yet, or the project processing has not been started here yet, you can delete the project. But once you start the project processing, you would not be able to delete the project. Okay, so I'll start the processing now, and you would see that it would give a alert here that if you start the processing and you have photographs which are not related to the project, your area would be distorted. So that everyone needs to, or the surveyor need to make sure that there are no junk photographs in the project. Okay, so once we click yes, you can see there is yellow button coming here which is saying this project is in the processing, and you can see the delete project has button have been deleted, and it is actually this delete project have been vanished from the project. So now you cannot delete the project. So this in processing button would become green, and the text would become completed in case the entire project have been processed. Now you can close this particular Surveyaan GeoWorkspace, and you can chill and relax. And once the data have been will be processed, you will be getting a auto generated mail on your mailbox. So because the entire processing is working in the cloud, so that is the benefit when you are using cloud software. So you don't need to be always on the software screen, and you will not all you don't need to be always monitoring the process of entire processing. So that would save your time, as well as that would save your computer resources, and you can work meanwhile on other projects or on other commitments while the data is being processing. So now we will move to how project looks like when the data have been processed. So there are few projects which are there in this in this account, in this particular account. It is our company's account. So I would search one project. So this is this particular project. So we would go to 16 hectare demo, and you would see that a completed button is showing here. It means the project have been processed and the output is available. So these are all project photographs, and you can see this particular project is of GCP. So 5 GCPs were used in the project, and these 5 GCPs are visible on the map. So if I go into the project output, you can see now it is not coming, like the project output have not been generated yet, and you can open the project explorer. Okay, so if you open the project explorer, you would see the area which have been processed will be shown here on the top of Google Earth. So you can verify the map. You would see that roads and the map, drone map would the roads which are in the drone map and the roads which are actually in the Google Earth would be overlapping each other. It means the data have been generated with quite a good amount of accuracy. So if you could see, this is the top layer is the drone map which have been generated, and if we go to the lowest transparency, this is the Google Earth map. So in this particular result explorer, there are two options. One is measurement tool and one is calibration tool. So we would go into the measurement tool for now, and once we go here in the measurement tool, you would see that there are many saved measurements available here. So these save we can actually save the measurements in entire project. I would show how can we do it. So suppose so there are 5 measurement tools. One is location measurement, another is distance measurement, other one is elevation measurement, other one is area, and the volume measurement. So suppose if I would like to see the location of this particular point, okay, so I would go here and I would click on this particular location, and you would see that the location would be shown in latitude, longitude, and altitude. This latitude and longitude are actually in the degree, minute, and second. If you want to change the degree, minute, second into the DMS, degree decimal, like if you want to change from DMS to degree decimal, you could probably do it. So for now I'll save this location. So location webinar, okay, I would save with this name, and you would see that this particular location have been saved. Okay, so location webinar, okay, and it would be shown here. So anytime when you open the project again, you click on this particular location, you will get the latitude and longitude and altitude of that particular location. So if we just go a little back, and there are two options, export and units. If we click on the units and the position format, if we select degree decimal, in this case, if you again go to the measurement tool and select this particular point, you would see that latitude and longitude earlier, which was shown in the degree, minute, second, it is shown in degree decimal now. Okay, so this can be done using the unit dimensions, or in the unit section we can change those things. Number two, there is a distance. So suppose if we want to measure the distance from here to, for example, here I'm just taking a rough measurement. If you click here, and you would see that you are getting two distances. So one is normal distance and other is the 3D length. So in 3D length, actually the elevation data is considered, whereas in normal length only the latitude and longitude is concerned, altitude is not concerned. You can save this particular distance also, so that can be done using the same way in which the point was saved. So distance webinar, okay, then I would save it. So once I save it, it would be reflected on the map. So whenever you select this particular thing, you would get the measurement. Okay, this in the same way there is elevation. So suppose if this is a small mountain kind of land here, and if I wanted to see what is the height of this particular mountain, so I'll click on the lowest elevation and click on the highest elevation, and you would see that you would get what is the elevation of from this point to this point, and also you would get a profile how the land is going. Okay, and if you go through this particular curve, the same point would be reflected on the map as you are seeing. Okay, so in this profile has been made with 10 centimeter 10 centimeter points. So on this particular line, at every 10 centimeter there is a point which is showing here. If you want to reduce that particular resolution, you can probably do it by changing the resolution. Suppose if you wanted to have 1 meter and then recalculate it again, the point have been reduced now. It is not visible because the graph is quite small, but if I further reduce the points and I take 5 meter interval and recalculate it, you can see there are less points. Okay, so in this the same way you can select how many sample data you want. Also, whatever the sample data you are getting here, you can export them. So once you export them, you get a CSV file. In the CSV file, you actually get the UTM coordinate of all the points, all the sample points, like their northing and easting, as well as the altitude corresponding to that particular northing and easting. If I'll open this particular CSV file, you would be able to see it. So these are northing and easting. So the software would automatically select the zone. So if it is because this data is of Rajasthan, so the coordinate system is 43N. So this northing and easting is automatically based upon what is the location. So if it would be Odisha, it would be 45N. Okay, and now it is Rajasthan, so it is 43N. So that would be automatically selected, and elevation in the meter would also be given corresponding to these points. We give latitude and longitude for user convenience purposes. If they want, they could use the latitude and longitude also, and they can actually use this point to import the data into the AutoCAD software. So so this way you can save you can see the measurement. Also you can save the measurement in the same way, the point and the distance have been saved earlier. Okay, then we can say calculate the area. So to calculate the area, just mark on the area and you would be able to calculate it, and you would see the area. Okay, and the same way you can calculate the volume also. Suppose if you wanted to calculate the volume of this particular section, you just have to mark a area around this particular section, and you would be able to calculate the volume in seconds. So suppose this is the area, and so in the volume calculation we have three base plane methods. One is lowest point base plane elevation method, in which all the points which we have selected in the on the polygon, actually among all the points, the whichever the lowest elevation would be, at this particular elevation a plane would be created, and then volume would be created, like how much volume is above that particular plane and how much volume is below that particular plane. So the volume which is above that particular plane is cut volume, and volume that is below that plane is fill volume. The similar there are one more method that is called average point method. In average point method, whatever points we have selected on this polygon, their elevation would be averaged and a base plane would be created. So based upon this we got the cut and fill volume. In a similar way, if you want, you can enter the manual base plane also. So in the manual base plane method, what we can do is I need to find out what should the manual base plane should be. So for now I'll save this measurement. So volume webinar, okay, and then I'll see what elevation was there. So I'll see the location. Okay. So it was 572.73. Okay, then I'll again go to this volume and I'll select 572.73 and then I'll calculate. So as you can see, if I'll select this particular base plane, I'll get to fill and cut volume. So basically you can select any method, and based upon that particular method you can calculate the volume. So these are basic elevation methods which we have right now in the Surveyaan GeoWorkspace. Then if you go to the back, you have one more option called export. So in the export section, I'll delete the earlier available contours. So in the default formats, you have the orthomosaic. So what is orthomosaic? So orthomosaic is ortho rectified image of entire point cloud data. So from the multiple photographs, actually the photogrammetry software like Surveyaan GeoWorkspace create millions of points on the area. And if we see the top view of that particular top view of that particular point cloud data, we would get the orthomosaic image. So it is ortho rectified. What is actually the ortho rectified? So suppose if I'll capture an image here, you would get the right section of this particular tree, and if I would capture the image here, you would see the left section of this particular tree. But when the entire data is ortho rectified, you would get only the top view of entire tree. So this is called ortho rectified images, and you can actually export the ortho rectified images using this particular export section. And in the export section you have geotiff and the word file. So geotiff can be exported from here and you would be able to download the data. So right now I have pre-downloaded data available with me, so I would rather use that particular pre-downloaded data. So you can download in that way. Whereas in the DSM, so what DSM is, in the DSM is actually a elevation file. So at every point on this particular land you would get the latitude, longitude and elevation, but you would not be able to get the RGB data like you are seeing right now in the orthomosaic image. With using the RGB data, you can actually see what all things are available on the land, whereas with the DSM data you can see what is elevation of that particular point. So using this two DEM and the orthomosaic, you would be able to get everything on the land on the surveyed land. So orthomosaic is actually used to see what all features are on the land, whereas the DSM or the DTM are used for getting what is the elevation on that particular land. But now the question comes, what is the difference between the DSM and DTM? So in the DSM, there are house, there are trees. So all those features are actually available on the DSM, whereas on the DTM these features would not be available. So DSMs are actually used to calculate what is actual distance on the land, actual elevation on the land, whereas the DTMs are actually used to generate contours on the land, because when we are generating the contours are only generated for the land, not or generated only for the terrains, not for the houses and the trees. So as the DTM file doesn't have those things, doesn't have those features, so we can use the DTM files to generate the contour, whereas we can use the DSM file to see what all elevations are actually available on the land. So these are the two difference between the DSM and DTM. So suppose if I want to generate a contour, okay. In the so DTM can also be exported in the geotiff format, which is actually useful for the GIS softwares like QGIS, ArcGIS, Global Mapper. So these softwares can import this particular geotiff format. So we can again export this particular format, and that would be we would be able to download this particular format. uh, Whereas these contours and point files are actually used in the AutoCAD, because AutoCAD cannot import elevation like DM's geotiff. AutoCAD can import Orthomosaic's geotiff, but cannot import the elevations geotiff. For that, we can use the contours and point features available in the Surveyaan GeoWorkspace. For example, if you want a contour, I'll do it and I'll generate the contour. So it would ask what should be the interval. So suppose if we select 1 meter interval, and then it would ask what area we need to filter out. So you would see that there are small stones are here. So suppose if you don't want to see them in the contours, what would you do? So we would mention here like if there are any close contours on the map which are getting generated, and if they are below a particular meter square of area, we would filter them out in the contour. So in that way we can filter multiple small contours from the area. So suppose if you select 30 meter square 30 so if there are any close contours in the area and they are below 30 meter square, they would be automatically filtered out. So we can export it. So it is not like all the contours are available with them with the Surveyaan GeoWorkspace. So these requested formats would go into the processing, and it would take hardly 1 minute to process the entire data, and then you would get a blue colored link here once the processing has been done. We would wait for the half minute, and you can see less than in the half minute the DTM contours have been generated. So you can then click on this blue link, and you would be able to download the contours in just few seconds, because the files are very small. In the same way, you can also generate the points which are AutoCAD compatible. So in the points you actually need to select at what grid you want that point to be. So if it is 5 meter by 5 meter, you need to select 5 meter. If it is 10 meter by 10 meter, if you want contours, not contours, points 10 by 10 meters, you can select the 10 by 10 meters. So I'll select 10 by 10 meters and then I'll export. The same way it would happen here also. It would be in the processing, and it would take hardly half minutes to process the entire DEM and generate the points. So once it would be done, it would be in the blue color. Okay, the points you can also download. So I have done these two things with the DTM. The same thing can be done with the DSM also, but in the just there is only one difference in the DTM and DSM is, as I earlier mentioned, in DTM there would not be elevation available, like elevation available on the trees and on the buildings would be the ground elevation in the DTM. Like we would filter those elevation out in the DTM, whereas in the DSM these elevation would be available. So it is basically users concern, like what file they actually want to generate their entire data. If it is DSM, they can done the same thing with the DSM. They can use the contour feature and they can use the point feature. And if they want to generate using DTM, they can use the same. Okay, the procedure is similar, quite similar. So if I'll open the contour file first in the AutoCAD, you would see. you would see the contour is generated using the DTM file, and these contours, all contours are labeled contours, and they are also 3D contours. So you can see the labels here. Okay, and if I'll change the view angle, you would see that these contours are actually 3D contours. So at every different elevations, the contours are available. So if you go to the layer properties of this particular auto generated file, you would see that there are four layers. So one is basic layer, which is empty layer, and then we have contour layer and the label layer. So labels are actually on the different layer, whereas contours are on the different layer. So for now, if we disable the contours, you would be able to see what all labels are there. Okay, and if we select them all, and if suppose we select their properties, you would see that you get the entire properties of the label, and you can change the label color by whatever your choice is, and also you can change the size of the label, like you can increase the size. So this is how we can increase the size, and once the size has been increases, you can actually go to this label explorer again, and you can enable this particular file, this contour layer, and you would see that the labels are actually big labels, and their color have been changed. So this is how you can change this particular contour file. And now what I'll do is the orthomosaic we have exported earlier. We can import that particular orthomosaic in the AutoCAD. So I'll select this orthomosaic, and I'll just have to drag and drop this orthomosaic here. We need to select first here, and then give a small insertion, like what scale we want to insert, and then what rotation we want. So select a random rotation here for now, and then a file would be imported here. Then there is a command called georeference img available in the AutoCAD. You can download using the AutoCAD app exchanger, and for more information you can go to our Surveyaan channel, and you would be able to see how to download the georef img, and you can see how to use the georef img into the AutoCAD. So right now I have georef img available in my PC. So in my AutoCAD, so I'll click on the georef img, I'll select the object, and I'll enter. So once you do that, your image would be automatically georeferenced to the geological coordinates. And now you must be wondering how it has been done. So there is a TIFF TWF file that is called Word file, which is available in the same folder in which this particular TIFF file is available. So, and they have the similar name, if you can see here. So this is actually georef img takes the reference from the TFW file, the Word file, and then it actually auto scale the entire image file in the AutoCAD. So this is what happening here. If I'll select this AutoCAD image file and then draw order to send back, you would see that there are contours, and at the back of the contour you have the image file. So if you want to further digitalize the data, like you want to draw the roads, if you want to mention where the locations are, where the tree, where the stockyard is, where the office is, you can actually create a new layer and you can start digitalizing the entire data. Okay. Now we have generated one more thing, that is point data. So if I'll select the point here and open the point data, you would see that a labeled point data has been generated. So at every point we have elevations label, and these points are actually georeferenced at a particular northing and easting. So their points are in the AutoCAD is at the same northing and easting, whereas their elevation is labeled at the point. So if I'll enter P type and change the points properties, like if I'll change the point shape and size, you would see them better. Okay, these points. If I'll select any of the point and I'll go to the properties, you can see the points geopositions are available as well as its Z location is available, and the same Z location has also been labeled on the top of this particular point. In the layer properties, there is similar way. The layer label layer is different and the point layer is different. You can change the label size and label color using the same way which has been done in the contour file. So also you can copy these points from here and you can paste these points into this particular file, and you would get contour as well as the points on this particular file. So that can be done. So this pretty much give the entire surveying data, because you got the contour, you got the point data, and you get the features, like you got the orthomosaic image through which you can extract the features and you can further digitalize the data. I guess this is what the surveyors want, and the same data they are getting in the AutoCAD, and now from these data they can further digitalize the map and then they could submit the reports to their customers. So this is from the AutoCAD side. Then we have one more option called 3D model. So entire 3D model would be exported from this particular Surveyaan GeoWorkspace, which can be opened in 3D Builder, 3D Viewer software, which are available in the in the Windows 10. And there is point cloud also, which is not quite usable file for surveyors in India. So most probably these three files are the major concerns which I have shown here. And there are two 3D model files, like point cloud is also a 3D representation and 3D model is also a 3D representation. Point cloud is cluster of multiple points, so points would be at 1-2 centimeter distance, each 1-2 centimeter distance. So if they are clubbed together, they would be seen as a 3D model. Whereas in 3D model, we actually create a mesh out of these points, and this mesh would be shown as a 3D model. So these 2 points are actually the 3D representation of the entire area. So pretty much in this webinar, and if you have any doubt, you can mail us at info@nibrus.in, and we would be happy to clear your doubts. Thank you very much. Thanks for joining.